All right, so if we take a look, the good news is there is nothing new today in terms of concepts. The only thing we're adding is a context. So it's not just here's a random quadratic equation. Find the random x-intercepts and some random vertex on it. We're going to provide some context to it so that the numbers that you're finding actually will make sense to you. Okay? They'll actually have a meaning to them. So that's what we're adding in today is meaning for the most part. Okay? Just a reminder again, you don't have to write this down, but just a reminder back to what we talked about yesterday. Standard form, vertex form. Okay? When you find the x-intercepts, remember it's always when y equals 0. When you find the y-intercept, it's always when x equals 0. Okay? I already told you the one difference today is that x and y are going to actually mean something. It's not just going to be some random thing. Okay? When we start going into applications, the number one thing that you're probably going to find is maximum and minimum values, which means which point am I going to be looking for? The vertex, right. If you're looking for a maximum, more than likely your parabola is opening down, and you've got a high point on the graph. If you're looking for a minimum, it's probably the vertex at the bottom of the parabola. I will tell you in general, when you're dealing with maximum and minimum type problems, most applications of quadratics deal with a maximum, because a lot of times what you talk about is like punting a football. You punt the football up in the air, what's the maximum height it reaches? That kind of idea that has that parabolic shape to it. Kicking a soccer ball, hitting a tennis ball up in the air, whatever it might be. Volleyball, those types of things. How many people are in physics? Projectile motion? That's all that is. It's just quadratics. Okay? Projectile motion is just following the parabolic path of whatever your projectile is. So same concept of what we're talking about here. So that's where we're headed. And again, you don't necessarily have to write this down because I've already talked about all of this. But if you're given an equation in vertex form, well then perfect. Pick the vertex out, h and k. If you're given an equation in standard form, which is usually what you're going to see, we've already talked about it in a homework problem. Opposite of b over 2a to find the x coordinate. Plug it back in to find the y. If a is positive, it's a minimum. If a is negative, you got a maximum. Okay? All right, let's get into what we're going to do today. Let's take a look at the first example here. And I've got a sheet for you so you don't have to write all this stuff down. Okay, so if we take a look, obviously there's not a whole lot of context around this problem. All I told you at the very top was that a ball is thrown from a tower. Got an equation of this one. H of t equaling negative 16t squared plus 64t plus 20. First thing I'm going to do though, I didn't give you a lot of units or any of that kind of stuff. I'm going to define what does h actually represent, what does t represent. What do you think h represents? Yep, h stands for height. And again, I didn't give you units, so let's just add some so that we have it. Let's say height in feet. So you're standing on top of a tower, you're taking a ball, you're throwing it up in the air. It'll get up to some maximum height, and then it'll come back down and hit the ground. Okay? T, what do we think T stands for? Time. And again, let's just say time in seconds. Okay. So that'll be the time since that ball leaves your hand until obviously the time that it hits the ground. That'll be the whole process. Again, let me go back to physics students for a second. Yeah, this is a quadratic equation, but this is not just necessarily some made-up quadratic equation. What's the significance of a negative 16 here in front? It's gravity. Physics, that's gravity. Negative 16 represents, or if you're working in meters per second, it's a negative 9.8. A lot of times if this was in meters per second rather than feet per second. So, okay, same idea. Okay, so it is not just some random, let me just throw a negative 16 in the front. That's gravity. That's what that's dealing with. So first question I have for you. I asked you to find h at 1. Not how do I do it, but what am I asking you to do?
Plug in 1 for h.
So that's the math. Plug in 1. But
The height of the ball after 1 second.
I'm asking you, what's the height of the ball after 1 second? That's what h of 1 is representing. Okay? And that's the number one thing I want you to get out of today is the meaning behind the questions and the answers. So I'm asking you for height of the ball 1 second in, which means all we have to do, like we talked about, plug in 1. If we plug in 1, you should get 68 as an answer. 68 feet. So 1 second after that ball leaves your hand, the ball is now 68 feet in the air. Okay. When we get to number 2, when I ask you the height of the tower, here's one suggestion I'll kind of always, to help you, I'll always give you in this case. Whenever there's a question coming up, they will almost always give you one of the variables, and obviously you're then finding the other one. Okay? So here, I'm trying to find the height. They're asking me for that, which means I must know something about the time. It's 0. Think about where this process starts. You're standing on top of the tower with the ball in your hand. So if you want to figure out the height, all you got to do is, when the time equals 0, how high up are you? And what's the answer to this one?
20.
Yeah, it's your y-intercept. That's really what this is asking you for. I'm asking you to find the height at time 0, which will give you the height of the tower. If we plug that in, we end up with 20 feet. Okay? So you are standing on top of a 20-foot tower. You throw the ball, 1 second later, the ball is now 68 feet in the air. Okay? Same idea, by the way, applies. If you think about this, again, in real life type of scenario, this is just pretty generic. But if you ever watch any of the NFL football games, and you see, I think any time they kick a field goal, they kick a field goal from wherever, and the ball goes, well, either through the uprights or not. But the idea is they'll almost always flash up that would have been good from 60 yards. This is all they're doing. They're just tracking the path of the football. It's, again, that projectile motion and saying, oh, if it would have kept going, they would have made that from 60 yards or 65 yards or whatever. That's where that's coming from, just in a much quicker way. Okay? So that's the idea. Same thing if you ever watch golf or anything. They track the path of the golf ball. Okay, same concept. Let's go to the next one. When does the ball hit the ground? So again, they're going to give you something, they're going to ask you for something. When I say when, what are they asking me to find? Okay, in general, it's the x-intercept, but when means time. How long does it take for the ball to hit the ground, which means you must know something about the height? 0. If it's going to hit the ground, that means the height is 0. So they're saying, how long does it take from the time you release the ball to end up hitting the ground? We need to find the x-intercepts. Okay, so let's go through and do that. We've got negative 16t squared plus 64t plus 20. We want to know how long it's going to take until we have a height of 0. So, here we go again, back to a quadratic, solving factoring or quadratic formula, one of those two. Regardless, by the way, though, what would you do first?
Take out negative.
Okay, yeah. You can divide everything by 4 or negative 4. It doesn't really matter which one. But regardless, that will at least make the problem simpler. Even if you factor, at least you're working with smaller numbers. If you go through a quadratic formula, it's smaller numbers. What do you want to do, 4 or negative 4?
Negative 4.
Okay, let's go with negative 4. I'm going to divide both sides by negative 4. Okay. So we end up with 4t squared minus 16t minus 5 still equal to 0 when I divide by negative 4. And now, once again, like we talked about in the homework question, maybe you can factor it. You could check the discriminant. You could actually do the b squared minus 4ac part. Matter of fact, let's do that just for something a little bit different. Because I know the answer to this anyway. And the answer is going to be we have to do the quadratic formula. So we might as well do b squared minus 4ac. And that way I can show you what I'm talking about. Okay. So if we do the b squared minus 4ac part, b, negative 16, when I square that, we get 256 minus 4 times the a value, which is 4, times my c value, which is negative 5. Am I going to add or subtract something from the 256? Yeah, we got two negatives here, so I'm actually going to add. So, and when we multiply, when we get a final answer, you should get 336. Is that a perfect square? If you're not sure, what do? Take the square root and see what you get. If it's a whole number, it's a perfect square. If it's a decimal, it's not. What's the answer? That is not a perfect square, which means this is not factorable. Okay? That's what I meant before when I had said, bless you. That's what I meant before when I had said if you just check b squared minus 4ac, if it's a perfect square, that tells you can factor it. If it's not, then you got to keep going with the quadratic formula. Nice part is, we've already found part of the quadratic formula now. We've got what's under the square root already. Bless you. So, let's keep going. X equals opposite of b, 16 plus or minus the square root of, but in this case I already did all the stuff underneath, 336. All over 2 times a, which in this case would be 8. Okay. Here's that same question that I asked you on the assignment. Reduce the radical or use decimals? Why decimals? We're trying to make this, the whole point of today is to make these numbers make sense. Again, if I'm asking you for a time, you're not going to tell me 2 plus the square root of 3 seconds. Okay? Doesn't make a lot of sense to anyone. So use the decimal so that we have that. Okay? What is the square root of 336? What do we get?
18.33.
Okay. 16 plus 18.33 all over 8. And now to finish this off, t equals. You take 16 plus the 18.33, so you get 34.33. Divide that by 8, and we should get 4 point something.
4.29.
Okay, so approximately 4.29. And then 16 minus the 18.33, so you get negative 2.33. Divided by 8 should be a negative 0.29. Okay. Negative 0.29. Now, last question. Which one of those is the answer?
The positive.
Yeah, positive one. The negative one is, again, you can't have a negative amount of time. We will come back to that to make it make sense why you got a negative answer. But right now, this is how long the ball is in the air. Okay? Takes 4.29 seconds for the ball to land. Once again, we go back to real life. Going back to the NFL again, they talk about punters and hang time and all that kind of stuff. Here it is. Okay, this was the hang time of the ball, if you will. Takes 4.29 seconds for that ball to go up and through the entire motion and hit the ground. Okay, so there's another way of looking at that. How we doing so far, okay? Let's keep going. So now they ask you what's the maximum height of the ball. What are they asking you to find? Yep, now we're looking for the vertex. How do I find the vertex? Opposite of b over 2a, because this equation is in standard form. Okay.
Can you still use the simplified version?
The simplified. Oh, you could, yeah. You could. I'm going to go back to the original, but you could do it, yeah. Opposite of b is what? Negative 64? If I double the a value from the original one, we have negative 32. Divide, it comes out to be 2. There's the x-coordinate of the vertex. And to find the y-coordinate, once again, plug that back in and see what we get. What do you get? Somebody said it. 84. Yep. If you plug that back into the original equation, you should end up with 84. Now, final question on this one. Which one of those numbers is the answer to my question? Yeah. I asked you what's the maximum height of the football. Well, that's 84 feet, or of the ball, I should say. That's 84 feet is as high as that ball goes. What does the 2 represent in this problem?
2 seconds.
Takes 2 seconds 2 seconds after that ball leaves your hand, it is at a maximum height of 84 feet. Okay? It takes 2 seconds to get to that. Okay? And finally, then I asked you to kind of just sketch a graph of the process and the points and the stuff that we've already found. So if we take a look, here's my sketch. Let's say this is the tower. Here I am standing on top of the tower. Ball's in my hand. There we go. We're good there. Okay. What did we say the starting point was? 20. So I can label that. We'll put that as 0, 20. There's that point. Then you throw the ball up in the air, comes back down, eventually will hit the ground. We said very first question I asked was h at 1 or h of 1. 1 second in, we were, what was it, 68? Is that right? 1 second in, we were 68. The ball was 68 feet in the air. We just found the vertex. 2 seconds in, ball ended up 84 feet. That was that maximum height. And the last point that we found was all the way over here. It took it 4.29 seconds approximately for that ball to land on the ground. Okay. Now, I told you I would come back to this real quickly. Remember, we did get a negative answer? The reason for that mathematically, it doesn't make sense according to the problem. If I continued this parabola, this is the negative answer that you found. Okay? You found the other x-intercept. It's there mathematically, but the problem isn't really starting until you get to that 0, 20, which is why we got rid of that. It doesn't make sense according to the problem. Okay? How we doing? Any questions?
If we used physics to solve these problems, we get the same answer.
Yep. Yeah, you should get the same answer. All right. Let's keep going. Ooh, that is not what I wanted. All right, take a look. I'm not going to do this whole problem. I stole this straight out of your book, and took the picture, took everything straight out of your book because it's similar to a problem that you're going to be doing. Plus, it's similar to what we just did. If you take a look, it's the exact same concept, except you're starting from a diving board and you're diving into a pool. So that same concept. Question A, how high does he start when he's standing on the diving board? How high is that off the water?
12.
Yep, it's right here. It's your y-intercept. 12 feet in the air. Okay. When I ask you to find the maximum height, what am I asking you to find? Vertex. Only part of this that I do want to go through and actually do is take a look at those numbers. Not so nice, right? Let's do a little practice here on some fractions. Okay? Opposite of b over 2a. Little fraction practice here. Opposite of b is negative 24/9 over, if we double the a value, what do I get?
Negative 8.
Yeah, negative 4/9 doubled is negative 8/9. Okay? Looks super messy. What do I do?
You just divide the numerators because the denominator's the same.
And multiply.
When we divide by a fraction, it's the same thing as taking the numerator and multiplying it by the reciprocal. So this is the same thing as negative 24/9 times negative 9/8.
So not opposite.
Okay? Not opposite reciprocal. That's going back to like perpendicular lines and stuff. Just the reciprocal. And now if we take a look, we can simplify. Negative times a negative is a positive. This 9 and this 9 cancel out. And 24 divided by 8. There's your answer. There's your x-coordinate and your vertex. So it went from something that looked super messy, and it cleaned itself right up. That is a negative. That's because that's also negative. Two negatives. That's why. So we found 3. And now if I wanted to find the vertex, I would have to go back and plug it back in for the y-coordinate, the actual height. Okay. Again, let's work through some fractions here again. Y equals, let's actually find it. Negative 4/9 times 3 squared plus 24/9 times 3. And then we still have the plus 12 at the end. All right, let's square the 3. So we end up with negative 4/9 times 9, which, what happens?
Negative 4.
The 9s cancels out, yep, leave you with negative 4. So there's kind of the answer for the first term. Now we move to the next term, what happens? Nope, just one thing. 3 goes into 9, 3 times. And 24 divided by 3 gives you 8. And then you still have the plus 12 at the end. And now we clean it all up. We end up with, what? 4 plus 12, 16. And there's your maximum height right there. Okay, 16 feet. Main reason I wanted to do this was the fractions. Just working with the fractions, working through the fractions, because I want you to be able to do that. Okay? All right, last question I have for you. A little different kind of problem here. Now we're going to go business side of things. And talk about revenue and cost and all that kind of stuff. We're not going to do the whole part. We're going to do the first part, and that's about it. But notice, if you think of from like a business side of things, maximize, minimize, we want to maximize the revenue, the amount of money that's coming in, while minimizing what? Your costs. Okay, the cost of running the business. You want to try to reduce those costs as much as possible, because if you have a lot of revenue coming in and not very much cost, that equals profit. Okay? That's what you want, is as much profit as possible. So this scenario, you've got a dog walking service. There's an equation that's kind of modeling the revenue, the amount of money that's coming in. Okay? So maybe you've gone through and you've collected a bunch of data, and this is what you have found that in terms of how much money you're making. Okay? P is the price you're charging per dog. Let's start with part A, and then we'll discuss. Find the revenue. Find the amount of money. If you were to charge $4 per dog, if you take 4 and we plug it in, what do you get for an answer on that one? Somebody do that for me, if you would, please. It should be like $400 and something. If you plug that 4 in and see what you get. It's like 412, 408, something in that vicinity.
Yeah, 408.
Is that what it is? 408? Okay. So you should get, if you charge $4 per dog, you get $408 is the amount of revenue that's coming in. Okay? What about $6? Actually, never mind. I remember this one off the top of my head. It's $468. Okay? $468. Which, by the way, makes some sense that you charge more, therefore you make more. Now, here comes something that might surprise you. What if you charged $8?
$32.
I believe it's $432. Okay. Why did it go down? You're charging more. Think about this in real life. What would be a reason in real life that now you're charging $8, but you're not making as much as when you charge $6? What is it? Could be a deal.
Supply and demand.
That's kind of what I was looking for. Think about it. There is a kind of a sweet spot, if you will, that you want to charge as much as possible, but not too much, where all of a sudden customers start looking and saying, they're charging too much, I'm going somewhere else. Okay? That's kind of the idea here. And that's the tricky part of a business, is when you're going through and you're trying to figure out how much to charge for a service or for whatever you're selling. You want to be able to maximize the amount of money coming in without charging too much for customers and turning those customers off and they won't actually buy anything. That's what this problem is all about. Okay? When you take a look at parts B and C, notice I say find the price that'll yield the maximum revenue. And what is the maximum revenue? What am I asking you for in B and C? the vertex. B and C are asking you for the coordinates of the vertex. Okay, the x coordinate and the y coordinate, which we've already done a couple of times, so we don't need to go back and do that again. Okay. How we doing? Make some sense, hopefully? Okay, your assignment, you'll appreciate your assignment for today. 5 questions. Okay, that's all you got. 5 problems. 5 questions.
It's 5 questions.